Hello friends, good morning. Today in this presentation we are going to have an overview about the OSI model, which is a generalized model developed by ISO, that is International Standard Organization for communicating between different devices all over the world. So we are going to study about this model, its various layers, its structure, its functioning, and how it helps in communicating between two different systems. All these points are going to be covered in this presentation. Okay, so first we are going to have the overview of OSI model. So here, as you can all see that in this diagram we are having two devices. One is a sending device and the other is the receiving device. These two are the devices in between which the communication is going to be performed, and they are going to be connected through a link with each other. So the communication between these two devices will be carried out with the help of the OSI model structure. Okay, so this model is a layered framework for communication across the system. That is, there are 7 layers in this model. Each layer has its different task, different application, and it helps in performing this communication. This layer serves to its adjacent layer, that is the layer above it and the layer below it. It is going to help perform some or the other function for the layer above it and below also. Also, this layer independently communicate with the same layer or at the receiving end also. Like in the diagram we can see that the physical layer, the very first layer of the sending device, it communicate with the physical layer of the receiving device through the connection, physical connection. Similarly, data link layer, network layer, all the layers are communicating with the other layer of the receiving side also. So they are communicating both way. They are communicating through the layers of the same side also and layer of the other side also. Okay, and now for this communication they have a set of protocols. In this model they have made a set of protocols, and you have to communicate, that is the device have to communicate using that set of protocols only. Now why the protocol is set up? This protocol is set up so that any two devices, they can be any far away, no problem, where it can be in the same area, it can be in a same city or different city, different countries, but if they have a same set of rules, same set of protocols, then they can easily communicate with each other. So that's why they have set up a list of rules, that is protocols, through which any two devices can communicate with each other. And this is a very generalized form of protocol, that is, it is easily understandable to any device. They are not very complex, they are just a basic set of protocols that any device can very well understand and can easily communicate or send data to the other side. So basically what we have seen, that this model help in communicating between the two simple devices through its various layers and set of protocols. So now we are going to study each layer one by one, that how it perform its function and how it helps in sending and receiving data. Okay, so the first layer is the physical layer. This is the most basic layer, physical layer. Its first important function is to activate, maintain and deactivate the physical connection. That is, whenever a sender wants to send a data to the receiver side, then this layer will establish a physical connection. That can be through any physical device or through a wire. It can be wired or wireless, both side. So this layer will set up a physical connection through which the data will be transmitted to the receiver side. Now, as in other topics you have already studied about this, that how data is transmitted through the various cables, that is optically, digitally, different sets of form. So here we are taking it as in a digital form. So you can see that the digital data that the physical layer gets from the layer above it. Now the which layer is above the physical layer? data link layer. So data link layer sends the data to the physical layer, and physical layer convert that digital data into a form that can be transmitted through the cable, that is accepted through the cable. Okay, so the digital data is transmitted into a voltage form, because it's an electrical signal. So the digital data is converted into electrical signal, transmitted to the transmission medium, and then that electrical signal is received at the receiver side. At the receiver side, the physical layer receive that electrical signal, and then it is again converted into the digital bit which it was earlier, and then this digital bit is sent upwards to the other layer. So what's the main function of this layer? To receive the data from the data link layer, convert it into a form that is acceptable at the medium side, and then send it to the receiver side, and the receiver side physical layer function is to again convert that data into the digital form so that it can be accepted by the data link layer side. So now this layer also defines the voltage and the data rate for the transmission. That is, it decide what should be the voltage and what should be the data rate, the speed at which the data will be transmitted. Okay, and also it also decided whether the medium used will use simplex, half duplex or full duplex method. Now this is a different topic in that you have to study at a different concept. Here I can't explain much about this, but these are the three types of communication systems: simplex, half duplex and full duplex, that are used for transmission in this medium, which you will study in other topics. So here what we have studied, that this physical layer may establish the physical connection, transmits the data, and when the data transmission is completed, then it deactivate the connection again. So this was the function that was performed by the physical layer. Now the next is the data link layer. Data link layer is the second layer, that is the layer above the physical layer. Okay, so the main function of data link layer is to provide a reliable node to node delivery of data. That is, it ensures that the data correctly reaches the receiver side. Okay, so what happens in data link layer? Data link layer adds a header and a trailer to the data. Now this header and trailer are added to the data because they contain the physical address of the sender and the receiver. That is, you are sending some maybe a letter to someone, then you have to write the destination address and your name also, that who is sending the data and where the data has to be sent. So this work is done by the data link layer. This header and trailer are containing the physical address of the receiver and the sender, that from where the data is coming and where it has to reach. So thus it helps in a reliable delivery, because when the data is having the correct information about the physical address, it will reach correctly to the receiver side. So these header and trailers help the data link layer to provide a node to node delivery of data. Also with this layer, it provides the error control and flow control. The trailer which is added, it helps in providing the flow control. That is, until the trailer of data is received at the receiver side, the sender side is not going to send the next stream of data. When they get the acknowledgement from the receiver side that yeah, the trailer is reached, that is the complete data has been received, then only the sender will send the next stream of data. So in this way they are going to provide the flow control also, that the flow of data be proper and in a particular manner of flow only. It doesn't overflow at the transmission medium side. Okay, so the main function of data link layer was to add the header and trailer and provide the proper address to the data so that they reach the receiver side properly without any error. So this was the data link layer. Now the next layer would be network layer. Okay, network layer is the third layer above the data link layer. This layer delivers the packet from source to destination across multiple network links. That is, network layer handles the network that is used between the sender and the receiver. Like here we have considered a single link between the sender and receiver, but in actual world it's not so simple na? There are many networks between the sender and the receiver, and the data can use any link which is available at that time. It's not necessary that always a single link will be available between the sender and the receiver. So network layer handles the link which will be used for transmitting the data from the sender to the receiver. Whichever link will be available, it will provide it to the data so that it can reach the transmission side. And then the next function of this layer is to translate the logical network address into physical machine address. We have already seen that different machines accepts data in different formats. Each machine have its own format of accepting data so that it can read it and understand it properly. So this layer functions is to translate the logical network address into physical machine address, because the link that will be there between the sender and the receiver, it will understand only the physical address, the machine language. So this layer and the data here was in containing the network address. So network layer transmits the network address into physical machine address so that the link understand what is the data, what is the address, and then it can send it successfully to the receiver side. Also, it determines the QoS, that is quality of service, by deciding the priority of message and route amongst the several. That is, network layer has the capability of deciding the priority of the message. Which message has to be sent first, which has to be sent second, which can be sent later. So by deciding this priority, it provide a better quality of service, so that urgent messages, like message which need to be reached urgently, can reach first at the receiver side. And next, it break the larger packets into smaller if the size is larger than the largest data frame. Here what happens, that there is a format of a data frame that it can transmit that amount size of data frame only. If the data we have sent is larger than the data frame size, then this layer will break the data into packets. Each packet will have be of the maximum data frame size only. Like if we it's having a size of 5 bits and we are sending a data of around 20 bits, then it will break it into 4 packets, 5 bit each packet, and then the data will be transmitted. So in this way, network layer handles the transmissions of data across the network, managing them in packets, and then rearranging those packets at the receiver side. This was the network layer. Now the next is the transport layer. Transport layer is the layer above the network layer, that is the fourth layer. This transport layer is responsible for the source to the destination delivery of the entire message. Now, what do you mean by the entire message? That in network layer we have seen that our data is break up into several packets of a particular bit size. Now, transport layer handles the entire message. Network layer was handling each packet at a time, but the transport layer is handling the entire message, whether it's of 5 packets, 4 packets, or 2 packets. So the transport layer main motive is to provide the reliable delivery of entire message, so that like if we have sent a message of 4 data frame, then it makes sure that the receiver also gets the 4 data frames completely intact in order. Means their arrangement is also accordingly which is sent by the sender. So this task is completed by the transport layer. It is handling the transportation of the entire message. And this layer also provides the flow and error control both at the source and the destination side. And transport layer assembles and reassembles the packets both at the source and the destination side, and it uses both connection and connectionless medium of transportation. That is, there are two different mode can be used: connection oriented and connectionless. Again, this is a different topic which we have to see differently at the other topics. So both the topics, connectionless and connection oriented methods, can be used by the transport layer for transmitting this data from the sender side to the receiver side. Okay, here in the diagram you can very well see how the data is transmitted there from the transport layer, and then next at the receiver layer. The next layer is the session layer, layer 5. Session layer mainly handles the synchronization between the communicating devices. That is, what does the session layer does? It add a synchronization bit. Here you can see after each bit it adds a synchronization frame, so that the data's order can be understood at the receiver side. Each bit of data, and then a synchronization bit, again a bit of data, then a synchronization bit. Like this, various synchronization bits have been introduced into the data by the session layer. These are also known as the checkpoints or the synchronization points. These are added at the session layer, and it helps in starting the dialogue communication between the sender and the receiver side. In case of any crash of data, that means that if the data is sent from the sender side, and by chance some amount of data is lost, or the complete data is not reached at the sender receiver side, then the receiver makes a check, and after that synchronization bit, it acknowledges the sender that I have got the data only up to this synchronization bit. So the sender will resend the message after the, like the data is reached till second synchronization bit. So the receiver will tell the sender that I have got only two synchronization bit. So sender will resend the data after the second one. It doesn't have to send the complete entire message again to the receiver side. It will send that data, that amount of data only which is not received by the receiver. So this helps in saving the data also, and time also. Like you don't have to resend again and again the complete data, only that amount of data which is not received, the sender comes to know, and it again sends the that data which is not received at the receiver side. So this session layers helps in providing the correct data at the receiver side. Now next is the sixth layer or the presentation layer. This presentation layer mainly handles the syntax and semantics of data. Syntax and semantics of data, that is, now the data security is also a major issue when you are communicating worldwide with many other different systems. There are always a chances of computer or system hacking, or your data getting leaked. If you are handling some important data, then you have to ensure that your data is safe also, because it is using many other networks and many other links to reach at the receiver side. So you have to make sure that your data is safe also. So that function is performed by the presentation layer. This layer encrypts the data. There are many methods of encrypting the data. This is again a different and a bigger topic of encryption of data that we have to study differently other than the OSI. So we are not going to get much deeper in this encryption, but here presentation layer handles the encryptions and coding of data, so that the encryption, you can say that while doing the encryption, they give a key to the data, and when the receiver reaches, the receiver has the key of that encryption, and it can decrypt that data only by using that key. So it makes sure that your data is reached only to a reliable receiver which you are intending to send. Any other receiver, if it's get in between the data, it cannot decrypt it without having the key. So we are giving a certain kind of a security to the data by encrypting the data. And also it helps in compressing the data. Now what is why data compression is required? Actually, now we are using different links, and many other systems are using these links to share the data. So by the method of data compression, you can compress the data so that it uses less bandwidth, and in a lesser amount of bandwidth, the complete data will be transported from the sender to the receiver side. So this data compression also helps in saving the data bandwidth, saving the amount of width that is required at the link side. So this data compression and encryption and encoding is done by the presentation layer. Now, the last layer that we are going to see, the seventh layer, is the application layer. Now, this application layer is usually performing the support to the direct user application. That is the database access, the emails, the file transfer, the higher versions of the user applications that are used. These are supported by this application. Means the data which is received by the receiver, to convert it into a format so that it can be accessible to other databases, to emails, to file transfers. This conversion of data format is handled by the application layer. In short, we can say that it's a kind of a talk between the computer and the software terminal, and software terminal to the host. That is, whatever data the host get, it converted into a software format so that it can be used in various other user application. And again, at the receiver side, the data which any user sends through the email, through the emails or through the database, it is converted into a format so that it can be transmitted to the next layers of the model. So the application layer handles these higher formats into the lower one. And through this layer, the computer feels that it is communicating with the host in its own terminal. That is, the communication between the user and the user and the presentation layer, it becomes easier with the help of the application layer. Like, for example, you can understand this by this, that like you are communicating with a Chinese delegate, then you need someone in between to communicate yours language into Chinese and then Chinese to English. So this kind of help is provided by the application layer in this model. It is communicating between the user and the system easily, and making the transfer more better. So this function is handled by the application layer. So this was the last layer of the OSI model, after which the data reaches the user in the format which it wants. Okay, so here we have seen how the data was transmitted from the sender side to the receiver side. So the sending device sending the data which is handled by the application layer. Then the application layer converts it and sends it to the presentation layer. Presentation layer provide encryption and sends to the session layer. Session layer provide the synchronization and provides it to the transport layer. Transport layer handles the reliable delivery of the entire message, and then to the network layer, which handles which network is to be required, which is available currently for the communication, then the data link and the physical layer. So this is how these seven layers are performing their individual functions and providing some of the other advantage to the data, so that they can be error free and reach to the receiver side without any issue. Now, as we know that every coin has two sides, this model is also having their merits and demerits. If we are going to see the merits, then the most important advantage of this model is that it is a very genuine and a generalized model. Like the protocols are so simple that it are easily adaptable, and any network can easily get into the model and agree to the protocols and easily communicate with the other sides of the network. So it is a very generalized form, nothing complex is there in the model, and easily any system can accept it and communicate at the receiver side. And also this model is supporting both the connection oriented and the connectionless system. Now, like we as we have seen that they are the wired network and wireless network, so it is applicable to both side of network. So this is also not the problem, any type of network will get support from this model. But the problem with this is that in this, the session and the presentation layer, they are usually no, not of much use, because if the systems are directly connected and they doesn't require much of the conversions, then this layer comes not much in use usually for most of the devices. And also some of the protocols, they were devised after the invention of this OSI model, so some of the new protocols are now not fitting into this model, so they are also giving some of the issues and problems while communicating or accepting these protocols. Rather than accept these some problems, this model has widely helped in communicating between the systems all over the world, and many countries, many users have used it successfully, and this model has helped them for years in communicating. I hope this presentation has given you a clear overview about the model and will help you in further. Thank you.